Good morning, Professor. Uh, our group name is the Fitness Guide, and today we would like to present about the health tracking applications. This is our health monitoring application is focused for the specifics for the gym trainer and the real time. If the gym player play the exercise, and if they want to detect the abnormal change and the trainer physical health during the workout, so the application advise the trainer or the modify the training and taking a rest, and then in the case of the accident, so we want to the player want to send the SOS message to the medic and the other responsible person need some help for the help. And this is our member. First one me, and the now second is Narodom and third one Nat. The user story is as a gym, I want to know my limitations. So I want to know where I can start at the right time. So yeah, this is the first scenario, and the second is I want to send a message, emergency message to the for the accident and on a wait. If I cannot leave the wait anymore, so I need some help. So this is for the emergency part. And the third is I want to monitor my heart rate and other hand precautions while play the gym weightlifting. So this is our smart monitoring system. Because of the time limitations, so we focus on the check our SpO2 and the ppm to predict the where to predict where we are, what type of exercise we are doing. So yeah, uh, this is our hardware, and this is the FICC and the the heart rate sensor. Uh, the next part is the where we not present about the how to integrate the sensor and the database and the other MQTT application development.
Is Professor still there? Is anyway, just talk about it. So for my part, I did the MQTT application development.
Nat, I didn't hear. Can you turn on microphone?
Sorry, I forgot to turn on my microphone. So for this project, in my part, I developed the base hardware by integrate the heart rate sensor with M560 board, and then I use the MQTT as a um, communication platform for data, and then also using the database to save the user data and user health data. And yeah, that's on everything I do. And then we know maybe we will share the video of the result first and talk about the technology later. So Luca, can you share the video? So this is the start of the device. So at first is we connect to Wi-Fi and connect to MQTT server. And at the moment it will show you the number, the list of user. At the moment, there are only 2 user. So we will push a button to select the user. Like at the moment, there are 2 users, and we will select the first user. This is a welcome message. And then a prompt will appear to ask us which exercise mode do we want. There are 2 modes, walking and running. And then if we choose, it will start measuring our BPM and SpO2. Because the screen is very hard to capture on the camera, we took the video on a special mode. So we put our finger on the sensor and it will measure the data. And at the moment, the data is quite noisy, but after it's stable, it will start sending data to the server and it will insert to the MongoDB database. And then here's the way we collect data, then we perform the working mode of the person. Exercise mode is now is a working. We will use this data to train a model later. Maybe next video, please. This is how the data is stored in our database. So we have two tables. One table is a user private data. At the moment, we only save the name, but yeah, we can put more information like telephone or like uh, grantor or some relationship. And this another table have not so many private data. It's only have user ID, SPO2 and BPM, and exercise mode. So if this is leaked outside, is there no privacy information is how can I say leaked, because on the information here user ID, we have two tables to track the health problem of the person. And maybe next video, please. This is to show you another feature of our product is a emergency button. So if we push the button and hold it for a second, it will send a SOS emergency signal. So we want at the moment it's a very simple application, but we can develop it into the like smartwatch application to send some SOS signal during the training session if the trainer feels not good about his health. And maybe next look I will show you a fourth video about how we implement machine learning into this device.
Okay, let's my turn.
This is yeah this is my part of for the this is my part for the product testing, machine learning model development for database, and the provision or threshold and test case, and the machine learning model implementations. So as the first me and Nak and then Narodom, and we use the we try to test our BPN and heart rate, and this is the data set of our data at the moment. So this is uh, for the timestamp ID and the SPO2 BPN and exercise modes. This exercise mode one is for the working, and one is for the working, and two is for the running mode. So after that, I implement and the MQTT and to like our train model. The train model, I train a model with the for the classification with the classification method, and then firstly I try to understand the data, and then second I select the feature and the target, and then split the data set, and training the model with the forest, and I make the our model evaluations. So this is our precision recording effort score. After that, I try to implement the MQTTF. So this is the and the MQTTF. Uh, we implement the model to our server, and then yeah, and then we have the some new data predict our power mode. This is the test video for with the model training. So other first, I'm stay here and my breath is normal. So this like just walking. So this is the walking, and then after that, I try to start to walk. And then I stay running for my SPO2 and BPN rate is related with the running modes. So this is show with the running. So yeah, the next part will be the will be represented by the Narodom. Okay, I stop my share screen.
Yeah.
Can I stop share this? Okay.
Yeah, I will share next. Okay, let's continue. Me and did you see my share screen? Okay. Let's go to the go to the web application. I developed the web application for the login each user and add a chatbot for from the Luca model and apply them to the Gemini AI and prompt this those context to the prediction result to one is walking and two is running. So it's a get activity is classified to the walking, and in a third case, if the user demo is a tree and the result is maybe unknown because I give the data is related to the predict. Okay, and I think it's user demo is a 4 case. Okay, and I have to okay, got it. And that data set I set for the true false. Okay, and I must to is unknown, and in other case is a prediction and result is 1, and then we have a lot of data for the training and for the ask the chatbot, and for the dashboard we have the if no user no account and we register and go to the board either the database and go to board at the exercise from the IoT, and if we go to we can log in and see the log and graph any and exercise and go to the what happened, and we can see the illustrate about the graph and heat map. Okay, and then we can edit the profile for the weight and calculate them onto the server and prediction again. Okay, and we for example I re-edit to 52 and it updates successfully, and then that's a finish for the web app, and then we go to the live bot, and I already update to the live bot for the chat in the chat and for the example in hello are you, and that the reply for the normal AI, and I add a little bit for the emergency alert to the live bot. For the example, if I get from the IoT from the exercise, and in this case, if support 2 and BPM is over threshold, that alert to the like Luca and Nhat present before. For the example, that emergency alert will show that, and in this case, if this below threshold, and for example, that normally not showing them. Okay. So then we go to the some a little bit to technical for development them, and I develop them by .env. I add a little bit from .env for the Google API key and for the AI and token like token, and some a little bit Mongo modify, and then we go to the prompt from the Luca. Luca is 10 model, already 10 model, and I export the model to the random forest model PK, and I keep the model to on the web app, and then we go to the and in this prompt, and I will add the context more for the make the prediction on the context and go to there, and that need to filter a little bit for the feature and for the input Luca model, and that output for the prediction result of Luca and display and input on the context to AI for the Gemini again, and that the result is like this. Okay, and then we go to the lightboard for the reply. I add a little bit for the on the here, and I add a little bit for the because that have a logic for the same API, and just add the API client and apply the reply the message and put message to the line, and they are required for the user ID to the send to who. Okay, and then I have application showcase to the those, and that's enough for the to this object. Okay, thank you very much, Professor and everyone.